Hello everyone. Let's go ahead and take a look at simplifying expressions. To begin, let's go ahead and start with some very important terminology. We have what is called a term. A term is a single mathematical quantity consisting of the product or quotient of numbers and or variables. So let's go ahead and take a look at some examples of some terms. 3xy to the fourth, 2z, negative 5xy to the fourth, and negative 3. So notice what we have is we have each one of these representing a quantity, and it is the product or quotient of numbers and or variables. Okay? Now we also have, for each one of the terms, what is called a coefficient. Now the coefficient is the number multiplied to the variable in a term. So if I go ahead and I take a look at this particular term, the coefficient is plus 3. The coefficient is plus 2. The coefficient is negative 5. Now notice this one says NA, and it's not applicable because of the fact that there's no variable in this term. Okay? Now, we can also talk about the degree of a term. The degree of a term is the sum of the variable exponents of a single term. So when we take a look at the variables for this particular term, it's x to the first, even though we don't write the 1, x to the first, y to the fourth. If we add those exponents, then we get a degree 5. This particular term, remember there's a 1 there, even though we don't write it. This has degree 1. And this here, again, notice that this is degree x to the first, y to the fourth. Therefore, we have a degree 5 term here. And here's, again, the situation where we have a term that doesn't have a variable. Now, of course, we said that there's no coefficient because there's no variable. And the degree of any term that looks like this is going to have a degree 0. And it's going to have a special name. It's going to be called a constant term. Of course, because the value of that term never varies. Okay, now that's what we can go ahead and take a look at and talk about when we look at terms individually. Now, once we go ahead and take a look at terms with relationship to each other, then we can go ahead and start talking about two terms being similar or like if they have the same variables and the variables have the same exponents. So if we go ahead and take a look at these particular 4 terms that we have up there as examples, there's 2 terms there that are similar. This term here is similar to that term there because of the fact that the variables and the exponents for each one of the terms are exactly the same. Now, what is the reason for being able to, what is the importance of being able to determine whether terms are similar or not? It's because similar terms can be added or subtracted from each other. Okay, so let's go ahead and take a look at a couple of other things here as well. It says the number of terms of an expression after being simplified determines the name of the expression. Okay, we'll come across an example of that a little bit later. The degree of an expression is the largest degree of all the terms, and of course this is after everything has been simplified. But how do you know if an equation is actually simplified? Well, if it is simplified, then all similar or like terms have been simplified or combined into a single term, and each term itself is simplified in terms of its coefficients. So let's go ahead and jump back to our example with these 4 particular terms, and let's create an expression. And notice that what we have here is we have 4 terms that are added or subtracted from each other. If we go ahead and remember that we said that this particular term here and this particular term here, those are similar terms, and because of that, we can go ahead and combine them with addition or subtraction. So I'm just going to go ahead and write them next to each other, and notice that what happens is that if I go ahead and I rearrange the order of the expression, I have to make sure that the coefficient of the particular term also remains the same when I go ahead and change its order. So notice that the negative 5xy to the fourth is moved here, and then this becomes plus 2z and minus 3. Now, when I go ahead and take a look at the similar terms and how to combine them, being that I know that this is 3xy to the fourth minus 5xy to the fourth, then I can combine those to come up with negative 2xy to the fourth plus 2z minus 3, of course, because nothing can be added or subtracted to 2z, because there is no similar term in the expression that's similar to this, nor is there another constant term that can be simplified with the negative 3. So this is as simplified as it can get. All similar and like terms have been simplified and are combined, and each term itself is simplified as well. Now, when we go ahead and talk about the degree of the expression, we're going to take a look at the degree of each one of the simplified terms. This has a degree 5. This has a degree 1. This is degree 0. So therefore, the degree of the entire expression is the largest degree of all the terms, which in this case is 5. Now, when we go ahead and think about how many terms we have 1, 2, and 3 terms. Therefore, this is going to be called a trinomial. Now, this is just a real quick question for you, and hopefully you can go ahead and just take a look and see if you can find out what the answer for this is. But what are the names of the expressions with 1 or 2 terms? Okay, let's go ahead and wrap up. Remember, when we talked about simplifying expressions, there's some important terminology to remember. One is a term, the coefficient, and the degree of the term. Once you go ahead and create an expression which is composed of the addition or subtraction of terms, then we want to make sure that we can actually go ahead and simplify the terms by making sure that all the similar like terms have been simplified or combined, and each term is simplified. Then we can go ahead and talk about the degree of the expression as well as the name of the expression itself. Okay, so we'll go ahead and take a look a little bit more at some of the examples in the book and practice some of these problems the next time that we meet in class. So see you next time. Bye-bye.